Alright, welcome back to our second part of our going through of our theory workbook. So let's look at question 2. Today's question, we will focus more on the dangers and hazards of electricity. Okay, so which of the following is the most suitable fuse rating for 3000 watt, 240 volts? This is your power. This is your voltage. We can find the current flowing through using P equals to V over I, subbing 3000 as power, 240 as potential difference. We can find the current. But remember, to find the fuse rating must be slightly higher than the operating current. So if 12.5 is operating current, we need something higher for the fuse rating. So the next one will be D. Okay, so let's look at question 4. The outer metal casing of electrical appliance is often earth. Which of the following is not true about the earthing of a metal case? There's only one answer. It allows current to pass through when the appliance is operating normally. If the appliance is operating normally, there should not be any current at all. There should not be any current in the earth wire, so that's why this is false. So answer automatically is A. Okay. The earth wire is to protect, is to drain out all the current. Let's say if your live wire touches the metal casing, you want to actually have an earth wire to provide a path of least resistance, electrical resistance, so that the currents will be able to flow through this path down into the earth and not into your body and cause an electrical shock. Alright, number 5. Light bulb is connected across the live wire and neutral wire in the circuit. What happens to the bulb? If the live wire and neutral wire interchange, the bulb will work normally. Why? Because the wires are just wires. They're all both made of copper. You switch them around, they are still wires made of copper. The bulb will still function. But then you say, but the live wire is brown and the neutral wire is blue. Yeah, that's just the insulator that's covering it. It's just for us to easy to identify. Okay, so answer is D. All right, let's look at 1, B and C. So we were on the topic of where the kettle is heating up by the heating element. State the meanings of the terms live and neutral. So live wire is connected to a high voltage. In Singapore, is connected to a voltage of 240 from the main supply. It delivers current to the kettle. The neutral wire is connected to zero voltage. It's usually a zero voltage. It completes the circuit, so it closes the circuit loop and it returns the current back to the main supply. C. Under normal operating conditions, what is current? So if it's operating normally, your earth wire should have zero, as explained earlier. There should not be any current in the earth wire. If there is current in the earth wire, it means that your device is dangerous, it is going to malfunction. And if you touch the metal casing, you'll get electrical shock. So the live wire and neutral wire itself, if under operating conditions, the current should flow through the loop. What goes in must come out, like water. Live wire, if there is 10 amperes, neutral wire should have 10 amperes also because it flows through the whole loop. Where is 10 amperes? Down here stated is 10 amperes. Okay. Let's look at question 3. Okay. Looking at the plug itself, I will not go through. Just be careful of the color. Okay. Let's look at B. Name the component between X and Y. So we're looking here itself. This is what we call as a fuse. You don't have to write the cartridge. Just write fuse is also fine. Name the component labeled Z. There is a called grip. What is it used for? It's basically one of the hazards of electricity is damaged insulation. Describe the hazard and damaged insulation itself. Okay, so in this case, the damaged insulation occurs when the insulating material surrounding the cable cracks or wears out due to wear and tear. And what will happen in this case is you will expose the wires inside. The live wire is able to conduct. It may cause an electric shock if people were to touch it. If the neutral or earth wire touches this exposed wire, short circuit may result and a fire may occur, because when there's a short circuit, means there's lesser resistance. If there's lesser resistance there, means the current that comes in will be very, very large. Large current will heat up the wire. The wire itself will get hot. It may result in fire. Okay. Okay, let's look at question 5. Sorry, question 5 here. Okay, shows a household circuit where there's an aircon with the following power and potential difference. And there's also a lighting unit with the following power and lighting difference connected to a mains of 200 volts. So you can see from the circuit here, The fuse rating in this circuit is 10 ampere. With A, our calculation, explain whether this fuse rating is suitable. So you want to find the total current that is operating first. So what do? Calculate the current for the air condition. Because we have P equals to VI or IV. You have the power, you have the V, you have the power, you have the V for each of the unit. You can calculate for the current first. So calculate the current for going through the air condition, calculate the current going through the lighting unit, that sum them up to have the total current. Why you sum up? Because this is in a parallel circuit. So if it's in a parallel circuit, the current flowing through here, assuming it's I1, and the current flowing through here, which is I2, they should add up. So the total current is equal to I1 plus I2. Okay. So if the total current drawn for normal usage is 12 ampere, you want the fuse rating to be slightly higher. So 10 is not a good number. You'll probably want a suitable fuse rating of 13, higher than 12. Okay. Why? Because if you use a 10, you turn on the switch, the fuse will just blow and you cannot use your device at all. So it doesn't make any sense. Step 2 advantage of using a circuit breaker instead of fuse. Circuit breaker can be reset easily if there is an excess of a current, while the fuse has to be replaced. A circuit breaker responds immediately, whereas a fuse takes some time because it has to get enough heat before it melts. So it's not as responsive. Okay. All right, let's look at section C, question 2. We have a refrigerator here. There is a main supply X, live wire, and there is also a neutral wire Y. Okay, I already give the answer. X is the live wire as it has a fuse connected. So one way to identify live wire is to find the fuse. The fuse is needed to cut off the high voltage supplied by the live wire to the fridge in the event of a short circuit. While Y is the neutral wire Y to close the loop. It has 0 volts, does not require a fuse. Set the wire to which a switch should be connected. It must be connected to the live wire. This will allow the high voltage provided by the mains to be disconnected to the fridge. Okay, so the next question is, do you put the fuse first, or do you put the electrical, or do you put the switch first? Yep, you should put the fuse first, because if you put the switch first, then it is not safe. If your switch is metal, then you may get electrocuted. You may get electrical shock. So put the fuse first. In the event there's a large current coming in, it can protect your switch also. Okay. See the purpose of the fuse. We have done this before. Safety device, prevent excessive current flow. How does it work? You're going to say that it's a short thin piece of wire. When the current flows through greater than the rated value, which is the fuse rating, it will get hot, it will melt, and it will break the circuit. Okay. To prevent electrical shock, a third wire is usually added to the electrical appliances. Name this wire is the earth wire. How can it be connected? And how does it work? It is a low resistance wire connected to the metal casing of the electrical appliances, and it links to the earth. So you got to say that it's linked to the metal casing and then it links to the earth. So this earth wire is connected to the circuit. Describe the events that occur when an electrical fault causes the metal casing to be live. So now your live wire touched the metal casing. What will happen? Because it touched the metal casing, what will happen is there will be a large current coming in. This large current will be conducted away by the earth wire to the earth. Why? Because when your live wire touches the metal casing, it causes a short circuit. The large current will flow through the live wire through the metal casing to the earth wire. In this case, what will happen is the fuse will blow and the electrical supply will be cut off. All right. So with this, we will end off for this part of the theory book. Thank you.